I received in the mail an AC Delco car radio for a 1959 Buick. Now this is a hybrid AM radio, so it has both vacuum tubes and a single transistor. And this one apparently isn't working. So we're going to check this one out and see if I can get it to work. Let's check this one out. Coming up next, an old Buick AM tube radio for the car. This one will be a 12-volt radio for sure. We know that because the filament voltage on the tubes is 12 volts. Let's pop the top off of it first and look for any broken tubes. Here's the model number. It's made by Johnson Laboratories. Made in the States. Is it going to focus? So 12DZ6, 12AD6, 12EK6, 12DS7 are the tubes that this one uses. Remove the bottom cover as well. At this state of the game, I don't know whether I'm going to be able to repair this or not because I have no idea what's wrong with it. But there's the lap. There's a light bulb in here to light up the display. And it should just unplug from the cabinet. 1 volt, 1000 microfarad, 1 volt DC. It's a fusible resistor on here. And I got a couple of capacitors. Now obviously there's going to be high voltages in here as well. This one doesn't appear to, does this use a vibrator or not? I don't think this one uses a vibrator. This one uses a solid state transistor to operate the inverter, the high voltage inverter. I think this is a solid state one. Wrong. This does not have a high voltage transformer. The vacuum tubes on this one actually operate at 12 volts. Okay, looking at this radio, it looks like this is the power input because it goes through this, whatever the hell that is, into the switch anyway. This looks like to be the power input. I was thinking this was an output for like for the to generate the high voltage, but I'm thinking it might be an audio output. This might be a single-ended audio output and feeding a transformer over here. It looks like this might be the speaker output over here. An audio output transformer. I don't know, it's weird. But definitely this looks to be the power input because it's going to the switch. So if I clip my power onto to here and to ground, when I turn it on, do we get anything working? It's drawing about 3 amps. Are the tubes lighting up? Check and see if we get any high voltage on any of the tubes here. Drawing about 2 amps of current. Are we getting any high voltage on any of the tubes? I don't see any high voltage. Curious if that's the speaker output. Just see if I connect this up whether I hear anything on my speaker or any noise or anything. That sounds like static. Let's just put something in there as an antenna. Let's see if I get any noise out of this thing. Sounds like radio static there is what it sounded like. Could this thing actually work? Oh my god, this thing works. This thing works. Incredible. It works. Cool. I didn't do anything to it.
Bloomberg 1061 Boston, Bloomberg 960 San Francisco, Sirius XM 119, and around the world on Bloomberg Radio.
This thing's pretty sensitive too. That's the antenna. Look, just a screwdriver.
Good morning from Hong Kong. I'm Brandon. And I'm Rashad Salamat.
A lot of things make noise in here.
Well, keep your eye on the dollars.
Let me put on my little test transmitter. All that racket you hear in the background, that's my switch mode power supply that's powering the unit up. That's what's making all that squealing. It's not the radio itself. I'll put it on a battery and you'll see. Okay, let's tune my little transmitter in. Well, I got to go back and check my notes and see what the fellow that sent me this had to say about it. Whether he just wanted me to check it over and recap it. He shipped it up from the States, and maybe he was under the impression it didn't work. But as we can see, it does. Pretty neat. So this is a tube front end, and the tubes are not running on high voltage in this case. They're actually running on 12 volts. There's no high voltage in this. These are low voltage tubes, and the transistor here, this is the output going through this transformer over here. Transformer gets warm because it's a Class A amplifier, not a push-pull, a Class A. So this transformer actually will be conducting current from the speaker output, which is this one here. That's the collector. And this is what's stepping it down, taking the DC off for the speaker. Yeah, my transmitter hums, I know. I got to go back and check my notes and see why, what his complaint was on this. But it definitely appears to be working. I wonder if this thing's shot, where you connect it at the back here. Maybe it's not getting any power through that whatever this is. Take a second to warm up here. for the tubes to warm up. Yeah, no, it's working. It's working. So I got to go back and check my notes and see what why this was sent in. It was a while back. This fellow sent me an email about this. But this old classic radio, this old Buick radio is working. He'll be happy. He'll be happy to see it just working at this point. We may need to change a couple of these paper caps, but unlike the high voltage sets, or we had a lot of paper caps, and these ones here are pretty low voltage, like across the 12-volt supply, and so forth. So there's not a lot of really high voltage capacitors in here that are going to cause a problem like they do on, say, a vintage table radio, which you have 200 to 300 volts on the plate, and the paper caps or paper condensers are used to block DC from getting to the next stage. I don't see a lot of that in this one here, but we'll look up a schematic if I can find it for this. Let's get to look at some of these paper condensers that are on here and maybe change a few of them out. And they're not high voltage ones, though. These are like only 50 working volt caps. All of these. 47 microfarads at 50 volts. I mean, they may even be okay without being swapped out. I looked at this lug here and thought, yeah, this looks like this is the power. And this is the choke coil to remove alternator hum and so forth. You see the coil goes onto this blue wire, which goes inside the radio. I'm thinking, okay, that's, here's the wire here going to the terminal, and here it's coming out here going into the radio. So I just incorrectly assumed initially that that was the wire. It wasn't until I actually opened the unit up and I looked at the power switch, and I found the power switch was going directly to this terminal, which went into this. I don't know whether this is a cutout or what it is. Maybe this is a capacitor. It's just formed by a couple plates with an insulation material between them, but goes to this terminal here. So this is the 12-volt input. So then I was looking at this blue wire, and this blue wire goes over to, goes down, it looks like it goes to this, down to this capacitor here. Or is it grounded? No, it doesn't. It's not connected to anything. It actually loops around and it goes to this transistor. So initially I thought this was probably maybe an oscillator to drive a transformer for high voltage, but it's not. This transformer here is actually the coupling transformer that couples the output from the tubes into the transistor. Looks to be driving the base of this transistor. Emitter is going through this little coil of wire, which I think is probably going to ground. Looks like it's going down to ground there. And the collector is going over to this transformer. You can see it's a transformer because if we look closely, we will see that here's the primary winding, right? The other side of that winding comes out and it goes to ground over here. If we look at the side of the winding that's coming out going to this terminal, it looks like there's two wires twisted together.
It's actually an auto transformer, a center tap.
Looks like there's two of them there. So this forms the secondary that drives the speaker. I should see if I can find a schematic for this thing. I'm going to go on the old vintage to see if we can find a schematic, then we can study the actual schematic together before I put this one back together. So this is a model 1968 12-volt model. Let me go look this up and see if I can find the schematic for this unit. So I got a print so we can study this radio. As I said, this is a hybrid radio. It has one transistor right here. Probably a transistor you'd never be able to get today. Old PNP would be a germanium transistor for sure. This is DS501. It is the audio output. If we look at the audio output transformer, which is the one on the back here, this is the audio output transformer there. You'll see how this is wired. I can find my highlighter pen. We look at our 12 volts. This is our 12 volt line. The 12 volt line goes through the choke. The choke that we're talking about here is this one that's on the back here. This would be the choke, this one here. That's to remove alternator wine, etc. And it's passed through it arrives down here at a 58 ohm resistor and a 10 ohm resistor, sorry, and a 0.47 ohm, which goes into the emitter of the output transistor. If you look on the back, this is the audio coupling transformer. Notice it's got a green wire, a black wire, and another red, and another looks like another green or blue. So the green wire is coming into the base, and the other side is going back through again our 12 volt supply. It's coming in through here, and this looks like this is either the tone control or the volume control.
That variable resistor is actually the bias, the DC offset for the output transistor, as it's a Class A output.
It changes, it's 110 ohm variable resistor with the wiper to ground. You notice that the 12 volts from the input also passes through this 10 ohm resistor, where it goes up to bias this transformer, and it's shunted to ground through control, and it's going to change this voltage, which is going to affect the voltage on the bias of this transistor, which is going to put the transistor more in and out of conduction. This is the audio coupling transformer. If we also look at the voltage coming off of the 12 volts coming in, it's going to also go through this coil here, and this is going to go off to the heaters, but it also goes this direction, goes up this way, through this transformer, out on the blue wire. The blue wire comes up, and this is the plate, going to the plate of the audio preamp way up here. Okay, so this is got a 12 volt DC. These tubes are operating the plate. The plates are operating at 12 volts on here, so you've got your 12 volts DC on the plate with your audio information. Now what happens is the 12 volts is going through, I'm just going to zoom the camera out a bit here just so we can see the full schematic. So the 12 volts is going to go through, the DC is going to go through this transformer up to the tube, and when the tube is amplifying the signal for the amplifier, you've got another bias here to this to one grid here. This is your tube bias. Your tube bias comes up from here. Let's use a different colored marker. Tube bias comes up through here. This provides your bias to the tube. It's fed through looks like a 5 ohm resistor here. Got 11 volts on it. This keeps the tube in conduction. The audio signal, this is the detector, this side here. So the RF coming in from the last IF stage, you've got your RF coming in here to the two plates, being rectified, and audio is now flowing out from being rectified on the detector. Audio is being picked off from the transformer here. Audio is going to flow down through this capacitor and into the volume control, and then up from there it's going to go to the grid of the
second half of that 12 DS7 tube to be amplified and sent back down into the audio coupling transformer, where it eventually makes its way into the base of the output transistor and creates audio on the output transistor, which then ends up at the speaker transformer. That's this other one that's on the back here. That's this one over here. You've got just audio on here. There's a 1.5 volt idle voltage on here. So it's going into the transformer. There's also a capacitor on here, which is a, looks like a 4 microfarad, looks like. The transformer here is actually, it's just a center tap. It's operating almost like an auto transformer, because there's no secondary. There's just a coil with a center tap. So one side is providing the path to ground to keep the transistor in conduction. Your audio comes off the center tap, goes into your speaker, which ends up back at ground. And there's a switch here to short the speaker out. I don't know where that switch is, but it says here output transistor will appear shorted if shorting type speaker switch is not opened. So that switch would be this thing here. It's not shorted now, but that's what that switch is for there. You see this little leaf switch here. What that does, I guess it's not even working on this, but there it is. There's a switch there. What that does is when there's no speaker terminal plugged in, that shorts out to ground. When you plug your speaker in, that opens that switch. Now the reason that's there, it's not shorting in this case because it's not making it, it's not closing completely. But the reason that switch is there is if someone were to turn the unit on without a speaker connected, you could end up with a high voltage because this transformer is expecting a load. You could end up with a high voltage kicking back and damage the output transistor. Also, if someone were to connect the power up to this speaker lug here, you would want to make sure that you blew the fuse. So that's what that does. But that's the switch there. Looking at the other path for 12 volts, we'll see that the other path for 12 volts comes up this way, and you've got one that biases this tube through a grid. It also goes through this transformer to bias this tube, and through this transformer, this IF transformer, over to the plate of the oscillator tube. This transformer is coupled. This side of the transformer, as you can see, is grounded through this 1.9 mega ohm resistor right here. So this one's going to ground. And it's not because it's a capacitor there. It's yeah, it is. It's grounded. It's grounded through here, through this through the 620 1 meg and 620 K resistor. So this side is held to ground. It couples the RF into the grid of the 12 EK6 IF amplifier tube. The IF signal then will come out of the plate, again through this transformer, and coupled into or in through the detector tube, which acts as your diode to strip the audio, provide you with your audio. The front end, the antenna, coupled through a transformer and a capacitor into the grid of the 12DZ6. But what's important to note here is that all these tubes are operating at low voltage, 10.6 volts on the plate. So we don't have any real high voltages in this set at all. The highest voltage is on here, 12 volts to the tubes. And we don't have high voltage capacitors that are going to cause issues like we would on a conventional radio. So I don't even think I need to change any of these capacitors out. This radio is working. I like the troubleshooting. It says, put your ear next to the speaker and turn the radio on. If a slight thump is heard when this is done, the trouble is in the tube stages. Try new tubes. If no thump is heard at all, measure voltage from transistor to case of radio. If 1 to 2 volts is present, transistor is operating normally, and trouble is either in the speaker interlock socket, or one of the tube circuits. If no voltage is present in step number 2, check the transistor circuit, and in particular the transistor fuse resistor, illustration number 59. This resistor is mounted between points 32 and 26 on the circuit board and should measure less than 1 ohm, because there is a fuse resistor for this transistor, and it's between, what does it say, 32 and 26. Here is the transistor fuse resistor right there. And that's right there. 0.47 ohm, and let's think about a 2-watt ceramic resistor. But I think this radio is actually fine, and I don't even need to do anything to it, because these are all low voltage capacitors, and we're not going to have an issue with them causing problems. I might be able to find a new 12-volt light bulb. I don't know if I've got one of these. It's a GE1891. Let me see if I can find a bulb for this thing. At least to replace the light bulb on it before sending this thing all the way back to the States. Costs a small fortune to ship this thing back and forth when there's really nothing wrong with it. I don't know whether he got the power mixed up. I sent him an email. I haven't heard back yet, or whether he just bought the radio and it was never tried. That's another possibility, is he picked up the radio and never tried it. But anyway, it's for a 59 Buick, so this radio will be going into a 59 Buick to increase the value of the car, keep it authentic, right? Tone control is actually up here. This is the tone control here, and it changes this. It adds this capacitor in. It changes it changes the value or the amount of signal that can be bypassed through this capacitor by lowering the ground point here, right, to this cap. This is the tone cap. This one down here, this resistor down here, and I was showing you before, this is actually setting the bias. So that's not one that's adjusted, that's one on the main board itself. That one sets the bias for this Class A single-ended output to keep the transistor in conduction. So you don't touch this one, because that will affect the actual conduction. With a single-ended output, because there's only one transistor, there's always going to be current flowing through the transistor at all times. And if you have your bias set too low, the transistor is going to go into cutoff, and it's going to sound nasty. You're going to have a lot of distortion. If your bias is too high, the transistor is going to be passing too much current all the time, even when there's no sound, and that will heat up the transistor for one, which could damage the transistor. It's going to heat up the output transformer as well, in this case a coil, and it's going to end up, you're going to end up with some voltage flowing through the speaker voice coil, just because it's going to happen. It has to, because there's no secondary on here. It's just an auto transformer to reduce that 1.5 volts, that idle, to get that idle voltage down. If you've got more voltage here, right? If you increase your bias, so in other words, if this is decreased, right? If the resistance is decreased here, the voltage will go up, which will bring this transistor more into conduction, and you'll have a higher voltage on the collector, which will make its way through to the speaker. So that one there is that's the bias adjustment. So we don't touch that one. This one here, this is the tone adjustment over here, and this one here is the volume control. I'm just looking at this to see whether I should be looking at changing any of these capacitors, but looking at this, I don't think there's any that I really need to worry about, because the reason you change the paper condensers, which just doesn't seem to have too many in it, on conventional tube radio, is because you've got high voltage and the stages are coupled together. So if your voltage is leaking, if your capacitor is leaking, and you've got your plate voltage leaking into the grid of the next stage, you can cause the tube to go into conduction, and then you'll end up with red plating the tube, which will burn out the tube, and it'll also burn out the next stage. This being low voltage, these tubes are actually biased quite hot to begin with a DC voltage. So I don't think a capacitor is going to really make much difference on this. There's actually not too many on here, and most of them are coupled to ground. They may affect the tuning of the IF strip, but again, when I stuck a screwdriver into the antenna terminal on the back, we've got basically 2 inches of an antenna, and it's pulling in stations from like 20 miles away. That's where the transmitter is, about 20 miles away from me. So without an antenna, without a proper antenna, this thing's pulling in stations from a fair distance. I don't think that we have to worry too much about any of the capacitors. Anyway, it's kind of a neat circuit, the way this one operates. Let me get this one together and we'll give it a final test. Get it like this. Protect this tube. The one tall tube, the other ones are all short, but there's one tall tube. They've got a cover on there just to protect it, to hold that tube in place and protect it from being damaged, from vibration, and from touching the top of the radio itself. So let's get the screws back in. I don't have a light bulb, but the guy that owns it, he can find one of these. It's just a GE 1891. They're relatively easy to find. It's just a standard 12 volt bayonet dial light. Light bulb just snaps in like that, so the fellow that owns this, he can just get a new bulb. Let's hook up the power. I'll actually put a proper antenna on this thing and see what we can pick up. So I got power hooked up. Let the tubes warm up. There we go.
A number of staff. Travel restrictions due to the pandemic have been kept.
I gotta turn off stuff that's interfering in here, such as all the inverter lights and stuff. Okay, I got rid of that horrible noise. That horrible noise was coming from my power supply that I was using to power the radio. So now I'm powering it with a battery. I just got a short piece of wire on here for an antenna. Let's see what we pick up.
1 and 2 bedroom condo starting at core negotiating positions.
Now the piece, I'm just running like a 5-foot piece of wire just strung across the shop here.
We're now near Vancouver. Lane closures both directions, and this is 20.
How you set the presets on this, by the way, is you pull the knob out and then you push it back in, and that'll save that preset. So if I go through.
And they're doing infrastructure upgrades on Marine between Victoria and Oak. Lane closures both directions.
And when the provincial government canceled the base decompiler here in Hamilton, we decided that we would go out
The ATM receipt, you're like, what do you mean you're broke? Dude, you have a comma.
There.
Andrew.
Interesting experiment with basic income here.
There.
Multiple times in the past. If they do that again, we'll give you updates as it becomes available.
Never get a Sharpie and...
Response. I'm Martin, my man.
7:36, sunny downtown tonight, sunny tomorrow, sunny Wednesday, sunny Thursday.
He's on the Judiciary Committee for decades. He knows these issues pretty well, and his instinct has always been moderate.
Working great.
At the members of the commission, it seems as if there are a lot of academics.
So now if I hit the button,
A lot of
we'll go to the station I set.
So let's just be clear here.
Internet, man, huh? Canada says it's
Representation on the commission there.
governments with the airline.
Why all of a sudden started?
Ferry sailing, any of them, all the routes agreed to several commitments, including a promise to
Turn it down.
Some originalism who are on the commission.
And my test transmitter here. Here's my test transmitter. Probably pick up without any extra wire other than this.
The company has also agreed to...
It's been reinstated for quite some time, but just a reminder. If it's
So that's
been a
the
while since
antenna.
You're at a BC ferry. And
Other than me touching the
make
wire.
sure you have that face mask or covering on you before heading.
Group says it's important to keep them first.
So I do.
So this one's fixed. Thanks for watching. We'll catch you in the next one. Bye for now.